Hi guys, so I'm going to do number 15 for you from the Module 7 packet. And the first thing we'll know is that it's going to be called g of x. Not that it really matters right now, but go ahead and start with that. It satisfies g of 0 equals -2. We plug in x equals 0 whenever we're looking for a y-intercept. So we have a y-intercept at the point 0, -2. Even if it wasn't an intercept, we would still want to rewrite this function notation as a coordinate. It has vertical asymptotes at -3 and +1 at x equals -3 and x equals +1. Now these will show up in the function as factors x plus 3 and x minus 1, and they'll show up in the denominator. So we can kind of keep those notes. We can put it together later. We have a horizontal asymptote at y equals 0. So horizontal asymptote at y equals 0. Now that happens whenever we have the degree of the denominator greater than the degree of the numerator. So we have to make sure that that happens in our end result when we put everything together. And we have an x-intercept at -1, 0. So x-intercept at -1, 0. X-intercepts show up when we set y equal to 0, as you can see right there. And when we have a fraction, 0 equals a number over another number, there's nothing the bottom can do to turn this entire fraction into 0. Actually, what it can do is reach infinity. But in our world, we can never reach infinity. So the only thing that can happen to turn this entire fraction to 0 is for the numerator to be equal to 0. So if we want to solve for the entire thing, y equal to 0, we're going to have to set the numerator equal to 0. And so we need to make sure that the factor x plus 1 is going to be in the numerator. Oopsies, not denominator. In the numerator. Because when it's in the numerator, I plug in -1, I'm going to get a 0 in the numerator, and that's what's going to cause that x-intercept. We have a hole at x equals 2. And this means that we have a removable discontinuity. Holes are the same thing as removable discontinuities. Other discontinuities would include an asymptote, so a factor in the bottom that gives you 0, but this one's removable, which means that that factor will cancel out. And it can only cancel if it's in both the numerator and the denominator. So that's going to give us the factor x minus 2 in the numerator and the denominator. So we put this together. Let's try and figure out where all these pieces go. I'm going to try not to move it up too much so you can still see some stuff. So I'm going to just make a big fraction bar, and we're going to put things where they belong. So the first one is going to be the vertical asymptotes. We have x plus 3 and x minus 1 in the denominator. We know that has to happen. Let's not worry about the horizontal asymptote yet. We'll go back and check based on what we have as a result. We have an x-intercept at -1, 0 means x plus 1 is in the numerator. Okay, and we have a hole at x equals 2, so we have to put x minus 2 in the numerator and the denominator. Okay, so we've done this one, we've done this one, we've done this one. We haven't done these other ones yet. So we're missing this one and this one. Let's try and figure out how those work in there. Let's start with the horizontal asymptote. It's only going to work if the degree of the denominator is greater than the degree of the numerator. Right now, we have x, and x is going to give us a cubic, or a degree of 3 on the denominator. So degree is equal to 3 in the denominator. And 2, we have x, and x is going to give us degree of 2. So we're good with the horizontal asymptote. We don't actually have to do anything for that. We just needed to check. I mean, if you needed to, you could have added or maybe like squared something on top or bottom, or raise it to a different power to keep everything in place, not add anything else. That would have helped. Let's try this very first characteristic though, where g of 0 equals -2. And we're going to check that out by just plugging in 0. So let's see what we get when we plug in 0. G of 0 is equal to 0 plus 1 times 0 minus 2 divided by 0 plus 3 times 0 minus 1 times 0 minus 2. And we end up getting 1 times negative 2 on the top gives us negative 2, divided by 3 times negative 1 times negative 2 gives us positive 6. So we end up with negative 1/3. But we want to get negative 2. So we have the negative in there. How would we change negative 1/3 to 2? And there are ways to do this, other ways to do this besides the way I'm showing you, but without actually changing or adding any new zeros, adding new vertical asymptotes, adding anything. Let's just multiply by a factor. Basically, we're going to insert a stretch in there that's going to stretch this out to end up at 2. And in order to do that, we would need to multiply this. So negative 1/3 times what basically is equal to negative 2. And the answer is 6. So if we multiply the numerator by 6, we know this is actually going to end up changing. Let's go ahead and just put it in there. 6 times 6. That 6 is going to cancel, and we actually just end up with negative 2, which is our goal. So go back up to the function we're working at here, and we just need to have a factor of 6 in the numerator. Usually we write it in the front, it doesn't really matter. So if g of x is equal to 6 times x plus 1 times x minus 2 divided by x plus 3, x minus 1, x minus 2.